A 100 microcoulomb charge is placed at the origin. A negative 50 microcoulomb charge is placed at x equals 2 meters relative to the origin, and a 200 microcoulomb charge is placed at x equals negative 4 meters. What is the net electric force acting on the 100 microcoulomb charge? So if you want to try this problem, feel free and pause the video to see if you can get the right answer. So go ahead and work on this problem. Now the first thing we need to do is draw a picture. So we have a positive charge placed at the origin, and that's the 100 microcoulomb charge. And then at a position of 2 meters relative to the origin, we have a negative charge with a magnitude of negative 50 microcoulombs. And then on the left side at negative 4 meters, we have a positive charge with a magnitude of 200 microcoulombs. So the distance between these two charges is 4 meters, and between the two charges on the right, it's 2 meters. Let's call this Q1, Q2, and Q3. So how can we use this information to determine the net electric force acting on the middle charge? First, we need to identify all the forces acting on the middle charge. So Q2 feels a force of attraction with Q3. Q2 is attracted to Q3. So there's going to be a force that's going to accelerate Q2 towards Q3. And we're going to call that force F2, 3. So this is the force on 2 due to charge 3. Now Q2 with its positive charge is repelled by Q1. So Q2 wants to move away from Q1. So there's another force acting on Q2, and that's going to be F2, 1. That is the force acting on charge 2 due to charge 1. And so the net force is going to be the sum of these two forces. Anytime you have two vectors that are parallel to each other, to find the sum of those vectors, you can simply add them. So the net force is going to be F1 and 2 rather, plus F3 on 2, or the force exerted on 2 by a charge 3. So we just got to add those two values. So first, we need to calculate each one. So let's calculate F2, 1. So it's going to be K times Q1 times Q2 divided by R squared, where R is the distance between Q1 and Q2. So K is 9 times 10 to the 9. Q1 is 200 microcoulombs, or 200 times 10 to the minus 6. And Q2 is 100 times 10 to the negative 6, divided by R squared, or 4 squared. So go ahead and type that in. So the force exerted on charge 2 by a charge 1 is 11.25 newtons. So let's save that answer. We're going to use it later. Now we need to calculate the force exerted on charge 2 by charge 3. So that's going to be K Q2 times Q3 over R squared. So K is a constant. It's not going to change. It's 9 times 10 to the 9. Q2 is 100 times 10 to the minus 6, and Q3 is 50 times 10 to the negative 6. Don't worry about the negative sign. These two forces are positive because they're both directed along the positive x direction. So you can adjust the sign based on the direction of the force. Now R, the distance between Q2 and Q3, is 2 meters. So we're going to divide it by 2 squared. It turns out that F2, 3 is equal to the same number, 11.25 newtons, purely by coincidence. So now we can calculate the net force acting on charge 2. So as we said before, the net force is simply the sum of these two forces because they're going in the same direction. So it's F2, 1 plus F2, 3. And so that's going to be 11.25 plus 11.25, which adds up to 22.5 newtons. And so that's the answer for part A. Now let's move on to the next part. What is the net electric force acting on the 200 microcoulomb charge? So that's on Q1. So let's see what effect Q2 has on Q1. Q2 repels Q1. So Q2 will cause Q1 to go in this direction. So we can call that F1, 2. That's the force exerted on charge 1 by charge 2. Now Q1 is attracted to Q3 because opposites attract. So we have another force, which we'll call F1, 3. That's the force exerted on charge 1 as a result of charge 3. Now these two forces are competing with each other. Now this force is in a positive x direction, so we're going to give it a positive number. This force is in a negative direction. So the net force is going to be the sum of these two values. If the net force is positive, that means that F103 is greater, which is probably not because it's so far away. If the net force is negative, which is probably going to be the case, that means that this force is greater. So let's calculate the values of each of these two forces. Now it's important to understand that F1, 2 is equal to F2, 1 in magnitude. They have the same magnitude, but the direction may not be the same. So the sign might be different. So technically, we should say that the absolute value of F1, 2 is equal to the absolute value of F2, 1, because one might be negative and the other might be positive. So we don't need to calculate this value because we already have it here. We do, however, need to calculate this value because we don't have that yet. So F1, 3, that's going to equal K Q1 Q3 divided by R squared. Now K is 9 times 10 to the 9. Q1 is 200 times 10 to the minus 6. Q3 is 50 times 10 to the minus 6. And the distance between Q1 and Q3 is 4 plus 2, or 6 meters. So this is going to be 6 squared on the bottom. And so the force is going to be very small. So I'm going to write it over here. It's only 2.5 newtons. Because the charges are so far away, the magnitude of the force will be greatly reduced. So now we can calculate the net force. It's going to be F1, 2 plus F1, 3. Now this force is negative because it's in a negative x direction. And it has the same magnitude as that one. So it's going to be negative 11.25. And this force is positive. It's directed in the positive x direction. So that's positive 2.5. And so the net force is negative 8.75 newtons along the negative x direction. So that's the net force acting on charge 1. Now for the sake of practice, let's calculate the net force acting on charge 3. Charge 3 is attracted to both charge 2 and charge 1. So the two forces acting on it will be directed towards the left. So it's attracted to charge 1 and the force between them is going to be 3, 1. That's the force exerted on charge 3 due to 1. And there's another force, which will be 3, 2. That's the force exerted on charge 3 due to charge 2. And we already have the magnitudes of these forces. F 3, 1 and 1, 3 have the same magnitude. And 3, 2 and 2, 3 also have the same magnitude. So the net force acting on charge 3 is the sum of F3, 1 and F3, 2. Now F3, 1 is going to be negative 2.5 because it's directed along the negative x-axis. And the same is true for F3, 2. It's going to be negative 11.25. So if we add those two values, the net force is going to be negative 13.75 newtons. And so that's it for this video. Now you know how to calculate the net electric force on a charge when it's parallel to two other charges.